So how did ANSYS work?
Very similarly, it was the same steps. You upload your geometry, define boundary conditions, generate your mesh, and then run the solver, look at your results, and maybe refine your mesh or your applied loads, and run it through until you have accurate results.
And did you always do a mesh refinement?
Not always. You usually do at least some kind of mesh study to see if your original mesh was of decent quality. If it was, it'll always spit out results, but it won't always be your right results. So you generally change a few parameters and rerun it and see how much it's changing. If you do some refinement or a coarser mesh and see if you get similar results, then go with the one that's less computationally heavy. Yeah.
Just a question to Tate. One thing that wasn't clear to me as I was looking at these course materials is when the students start learning how to use Abacus.
Today. So, ideally, well, at Mississippi State we have the Abacus licenses, so I don't know if you know an update on the license procurement for Liberty, but I think that they're installing it on the servers like as of yesterday. So we might be able to download and start using it soon, but you'll be given your first homework assignment soon, which will give you some experience with Abacus, but by and large you have your project picked out at this point, and it's up to you to go at your own pace to start stumbling around in Abacus, but there's not a lecture geared towards this is how you operate Abacus, because the idea is, as you've reiterated, is more about the fundamentals of FEA and the mathematical foundations and things like that. So it's up to the student to say, yes, I'm going to use Abacus, and now I need to start learning how to use Abacus and start working through it, which is where I am going to spend a lot of my time as a TA helping you guys work through Abacus struggles. So I will say, a slide like this, the purpose of this particular slide was to demonstrate how when you're going through the general steps of the FEA process, you start to acquire uncertainty. And so a point sort of needs to be made about how when you move from the CAD model that's fully featured and fully detailed, and then you import it into Abacus, what you'll find out is it tries to partition all the surfaces, and it's going to come up with a lot of errors. And it's going to say, I can't mesh around that weird fillet in the corner. And so you have to you can see that first bullet point under the arrow is defeaturing or idealization or cleaning up. And so when you're removing details, you're adding uncertainty. So you're moving from a more accurate to a less accurate, and that is the foundation of your calculation. Then with your loads, your restraints, material properties, and analysis, aka your boundary conditions, that is, and the biggest point of this is, that is the greatest source of uncertainty in the FEA process, is the approximations you make when constraining your model and when loading your model, and the math models that you use to run your calculation, and the errors associated with your mathematical models, and then you have the actual calculation that takes place, and that accumulates errors, and then you have the FEA post-processing or visualization, in which case you may get errors in how the color contour plot actually demonstrates or visualizes the actual stresses. Like the two red spots in there, those are actual errors in the visualization, which if you weren't aware of that or looking for that, then you would say, oh, that's the area of maximum stress. But having understood how the uncertainties and errors propagate up until that point, you can essentially eliminate that, truncate that data, something like that. So those are all sort of, this was a huge point of the garnering of the uncertainties within the process, and the largest source of uncertainties come from the applying of the boundary conditions. Would you agree with that?
Again, I don't have that much experience with this kind of mechanics code, so I would need to go through that learning process myself.
Okay.
But certainly understanding the model iterating, doing certainly mesh refinement, but trying to be aware of where the errors are, where the uncertainties are. That's a crucial aspect of this whole process.
Yeah, so this was sort of an introduction so you can visualize, but lectures from here on out will kind of dive deeper into the individual things, and so we can get a better understanding of how uncertainties are in your math models, uncertainties are in your geometries, and the mesh that you use, because we'll go over different mesh refinement techniques and things like that, where you can say, okay, I may be using one type of element, but I had no idea that there's, it deforms in a certain way that doesn't constrain as it should, so you get an error. So we'll go over all those in the element technology lectures and things like that, which are yet to come. So.
Okay. All right, we're out of time. Maybe just a few words on projects. I was wondering if you all had thought any more about what kind of project you might like to do.
Are you still thinking, I know the original, syllabus description was teams of 3 for a project. Is that still the idea? Are we all gonna work together, or is it more individualized? Because we were just discussing, we had a meeting with Dr. Lugo this morning, and looking at some more fatigue-based finite element analysis models that would supplement our research and be something publishable with our current efforts. So I think that would be something along the lines of like an automotive component case study that's fatigue loaded and trying to incorporate the MSF model into finite element analysis. But we just discussed that this morning. We'll get a better write-up and go over it with Dr. Lugo and then send it to you for review.
Okay. I guess I'm trying to remember. I think maybe Dr. Horstmeyer mentioned that possibility to me before the course started. So, and that certainly makes sense that you would take, apply what you're learning here in a way that would benefit you in your thesis work in your future. So, Paul, what kind of research are you planning? You're working under Dr. Horstmeyer, right?
Yeah, I'm looking at composite materials for football helmet shells, like composite thermoplastics. I was thinking maybe doing FEA analysis of that under applied loads, probably similar to what would be the case for an NFL game. I'll have to think a little bit more about it, talking about Horstmeyer.
So would that project on that be your preference? Would that be something you would?
Yeah, I think it'd parallel what I'm doing already in research more closely. So that might be a good project to do.
What do you think, Tate?
I think, having projects related more specifically to the research would be beneficial for these guys, at least, if they are challenging them with a meshing problem, challenging them with applying of different boundary conditions, and challenging them in a analysis of the results in the field of solid mechanics to some degree, and probably a dynamics or a dynamic explicit calculation. I would say, for instance, if you guys were to propose your own research-related topic, you would need to have a complex meshing problem associated with it, a complex boundary condition application associated, probably a complicated material modeling applied to it, and then to be able to visualize those results and show like the time history of your calculation in a dynamic environment. That's what I'd say about that.
I know various people have worked on the football helmet problem. Is there, did you work on that?
That's my thesis topic, yes.
Both these guys are doing the football helmet.
So how would what do you think about, you think Paul could do a good project, have a project for this class that fulfill the requirements of the class?
Yeah, we had kind of talked to Dr. Mark about this a few weeks ago, about modeling an impact on the helmet shell. And just from personal experience, that, meshing the shell and running a calculation, just modeling an impact with the helmet shell alone, it's complicated, but it's been done. So the more complicated project would be to model the head inside of the helmet with the foam and everything, and that would be a substantial problem that could be done in this class time frame. And if you were all right with that, he could basically assist me with that. That would be, or it would be his class project, but I would have I would basically drive that one. Because that's what I'm doing this semester, is trying to mesh that problem. So if he wasn't just doing a helmet shell, which is kind of simple, then he would be doing what I'm doing. So he could work with me on that, if that's all right with you, or he could try different material modeling paradigms within the helmet shell context.
Well, it's certainly a non-trivial problem. It's a serious problem. And if you come up to speed on being able to do problems like that, I feel like that would be, you'd fulfill the requirements of the class for sure. So I'm okay with that.
Okay.
So why don't we move forward tentatively with those two projects?
Okay.
I had a communication, I guess it was yesterday, Tate was on with Dan Harmony. I'm not sure what the status is for the Abacus licenses, but hopefully within days we'll get that accomplished.
Right.
And again, the one question was whether you wanted a Windows environment or Linux environment.
Yeah.
Which one do you typically use?
Windows environment to at least build the analysis jobs in. The pre-processing is all done with a Windows environment, and then we had to convert it all to Linux to submit through our supercomputer cluster. So, but that's a trivial line in the code whenever you're actually running those submissions. So I seconded your opinion to Dan Harmony, so I think you heard that Windows, and which that's what you guys all have booted on your workstations.
Right. Yeah, that'd be easiest.
Okay. All right, well, guess we'll end there. And I'll try to move forward trying to get you access to Abacus and get your projects underway.
Mm-hmm.
I can, once you have some access to Abacus, I can start assigning the homework. And so I think we're on track.
So do you
Any further?
Well, yeah, I was going to say that if you're following Dr. Mark's homework assignments, he actually assigned a more fundamental math, like find the weak form solution sort of homework problem. Like on the second or third homework assignment was that, and since you've already covered those fundamentals and they don't require any kind of FEA solver, you could submit that one, or you could assign that one early.
Okay.
So, that'd be my only.
All right, thank you for that. I'll try to do that next time.
And
Right.
for the final project, since we've kind of discussed what those would be, would you want like a write-up kind of discretizing the deliverables for each of our respective ideas by next week? Try to just get some parameters on that.
I think that would be helpful if you could do it by next week.
Okay.
My concern is whether you could have a good enough idea of what you want to do by then.
Yeah. I mean, I think I have it.
What we can do. I'm still trying to come to grasp with like exactly what the scope of a effective project would be. Something that isn't so extreme that like jumping into Abacus for the first time, just.
You can talk to me about it for sure.
Okay.
I've got, I think, the project list from last year. Do you have, the document with the final project requirements, like the sheet? I think,
I may have it, I haven't noticed it, and I haven't looked for it.
let me see if I have it. Let's see.
Yeah, we can,
Yeah.